Alright, hello and welcome to a new installment of, I don't know what to call this yet. Midnight repairs, late night amp restorations. We'll figure that out. Put it in the comments what I should call some of these videos. But anyways, the holidays are past. I've been sick for the past week. I've felt awful. I still don't feel 100% tonight. I'm like forcing myself to make this video just because I need to get moving on some stuff here. So bear with me tonight. Might be a little winded or boring video, but I'm still not 100% yet. But let's get into it. My desk is destroyed. That was on my to-do list. And my camera's nowhere to be found. Here it comes. See, I warned you. It's going to be a tough video today. Alright, oh, there we go. So tonight we're going to do an RPW-10. This is a trade-in amp. I sent a good one out, and this is the one that was sent back to me. So it's actually in pretty nice shape. I took the fuse out. Fuse is blown. So I already know what the problem is. It's glue. It's a glue failure. Almost always by the Pdc board. So we will take the power supply out. Actually, this is the power supply and the amp. This is the preamp up here. But we're gonna get that out and fix it. And I had a week off of work. And I had a whole bunch of stuff I wanted to do in the house, and all these amps I wanted to get caught up on, and yeah, like I said, I felt awful. My wife is sick now. Luckily we made it through Christmas, but we did not make it through New Year's. And I know with this virus going around, everybody's getting sick, so I guess this is just the new normal for now. Not much you can do about it. Just kind of deal with it. Let's zoom out just a little bit more. And I'm just taking the screws out of the plate here. I'm gonna need like some people watching and telling me what I'm screwing up on. If the video's not in focus or might need some help. This screw feels like it was Loctited in place. It is really tight. Either that or it's stripped. I hope not. Just tight. Hey, whoever owned this amp, they definitely took care of it. It looks really good. The colors look really nice. They still have that like gold color to them. They did everything right except for one thing. They left their switch on auto, and they didn't turn this off over here. So because of that, I get to work on it. And fix it and send it to somebody else's living room, and then they'll send me theirs, and the process will repeat until either nobody wants to pay to have these things fixed anymore, or I've fixed all of them and people actually start shutting them off. We will see. That's one more screw, maybe two more screws. I think this guy comes out. Yep, that's the last one. And it's gonna fight me, of course it is. Some of that lovely glue went shooting off of there. Hopefully it didn't go in my coffee. Probably causes cancer. Alright. There is the last one. And I can tell that this thing is just smothered in thermal goop. So we're going to try not to get that everywhere. Usually I am very unsuccessful at that. I already got it all over my fingers. Alright, here we go. Step 1. Remove thermal crap. Dirty paper towel. Cotton balls actually work the best. Anything. Just get all this shit off of here. I hate this stuff. Absolutely hate it. Too much of it actually acts as an insulator, not a thermal path. We're going to have to deal with it down on here too, because one of those transistors is surely blown. I shouldn't say surely, like 99%. I'm going to be drinking a lot of coffee too, so bear with me, because I have not had energy. Well, let's see what we got. Let's zoom in. Zoom in. There's our problem right there. So this glue that's holding this cheap capacitor in, right at the top here, has turned black, and it's touching our Pdc board, and it shorted it out. So we got glue here, we gotta remove that blob. We have glue down in here, that's gotta go. The glue up here can stay. This really isn't a problem. Sometimes it is over here, but I usually leave it on these pots unless it starts to turn brown. There's also a blob down here, but if I don't have to replace any of the outputs, I leave that alone. Let's see which one of our transistors is shorted. Probably both. My tip is coming loose there. The first one's shorted, so just this guy. My poor scope probe or meter probes have been abused so much they're all bent up. So we gotta replace the transistors. We gotta remove the PDC board. We'll start. Let me first start by heating up my solder sucker. That's step 1. But you guys got to keep telling me to zoom out. I'm gonna forget. My head's been in the clouds the last few days. So yeah, we're gonna desolder these 6 pins here to get the transistors free. Then we're gonna take the PDC board out. Since this has the legs full on it and it hasn't been clipped, we'll test it in my little test fixture. And then we'll go from there. We're going to do a full recap on the board. There's not that many caps. I actually have everything in stock now. Got everything in, and then I got sick. So I haven't been able to use any of them, but we got to check this guy here. Make sure that there's no burn marks through him. Usually when you blow a fuse, this guy blows. So, I mean, the best way to do it is just kind of bend it down. Look at it, you know, from all different angles, and just make sure there's no holes in it. And you'll clearly be able to see it if it's blown. This one's good. Let me try and find one that is blown. I probably will not have one. We'll get into this sometime. This is a nightmare sub 12 that I can't seem to fix. And it's just a problem with the power supply. I don't know. It's either a bad transformer or a bad diode bridge. Everything else has been checked and tested, but this one has been replaced. I don't have one, unfortunately. I thought I did. Let me check one more board that we're gonna need anyways, because this is my testing board. And he's already been replaced, so. This is a good sub 12 board. I use this for testing. What I might do is, since the sub 12s are a little more rare, I might repair and rebuild this one, put it into that amp that the board that I can't get going, and then I'll take another sub 10 or RPW-10 amp and turn that into my testing board. Alright, we're heated up. Let's start pulling parts. You gotta take the screws out before you unsolder the transistors. And these screws are sometimes a nightmare to get out because they're covered in like super glue basically. So just kind of be careful. If you can get them out without breaking the glue, that's the best way to do it. And the glue broke on that one. So now you have to get a pair of pliers and fight with it, because these do not like to come out. This one ain't too bad, but I'm squeezing pretty hard trying to get that, or keep that nut from spinning. Alright, once you get that out, you do need to make sure that it can move. So if it's glued down to the board, you're going to have to either snip that glue or do something with it. So right back here is one of the spots where it's glued, so we're just going to snip that. We'll clean that up later. Well, we can clean it up now, I guess. Only takes a second. And I'm just using an X-Acto knife just to scrape some of this off. Couple of different blades. Since this is a non-critical area, I really don't care what it looks like. Just get as much of that glue out of the way as I can. Try not to make a huge mess while I'm doing it. Alright, so that has that free. This is already free, so now we can continue desoldering. So I'm putting some leaded solder on these legs first, just because the lead free is sometimes a pain to work with, and I don't want to damage any of the through holes that are going through here. So a little bit of lead first goes a long way. And what I'm going to do is I'm going to try to wiggle this heatsink as I unsolder them. And this is sometimes successful, sometimes not. The goal is we do not want to break the through holes. I don't care about breaking the part. I don't want to break the through holes. I don't want to have to redo them. And we already took one of the rings off, so we're already in trouble. I already got to replace one. It figures. That's why I didn't want to do a video tonight, because I knew it was going to piss me off. It's the way it is. So 2 of them gone. And I mean, these are just the cheapest of cheap boards. You can see right there, there's the eye. Well, I can see it. Yeah, you can see it. There it is. Right there. That's 2. 2 eyes destroyed. So I'll put two new through holes in. I'm gonna do it the quick way, but still, it's no less annoying that you have to do that. some glue on this capacitor down here. I'm breaking it off. Just making sure that it's not going to screw up anything else. And there's some plastic, like super glue type stuff. Break that out too. So now we're free on that. Now the two leads that broke off, or the two pads, are actually top pads. If you wanted to, you could leave them because the connections are made on the top side, but it'll drive me nuts and I'll feel like I'm doing a crappy repair, so I'm just gonna bite the bullet and do it right. Does look like I lost one of my nuts here though. That's not good. I did not see where that went. Oh, one of those days. Well, there used to be a nut like this one underneath all that glue, but it is gone. It's probably in my coffee. So now we might as well just bust the other one off, because I don't know if I'm going to be using those screws. But I don't know what this shit is that they put on there. It's like liquid plastic or something. It's really freaking stupid. I wish they didn't use it, whatever it was. I'm just cleaning the nut up just a little bit. Try and salvage one. I'm going to have to find, I'm sure I have spares, but it's just annoying that I lost one already. I had no clue where it went. Unbelievable. Checking these like little pieces of plastic because they're shiny and looks like it could be one of the nuts, but it is not. Alright. Pdc board is next. I don't have a lot of faith in this board. I am convinced that since I took two pads off just pulling the transistors out, that I'll probably at least take one or two off pulling this board. There's really not much you can do. These are the cheapest PCBs you can imagine. But we will keep going. Get it repaired, and it's early enough tonight. Maybe I can do a few things because I'm so behind. Nope, I already see that I lost one there. I'm going to be replacing all these before the night's over. Sometimes that's the way it goes, I guess. What can you do? That one came off. Different boards behave differently. This one is just not being nice to me at all tonight. Probably because I admitted that I wasn't feeling good and didn't want to do a video, so the board's gonna just piss me off. Pull another one off, damn it. This isn't me. I'm not doing anything differently than I normally do. This is purely the board. It's the board just saying F you to me. So I'm sure that I'm going to tear off at least 2 doing the caps too. It's just this type of board. Alright, I mean, at this point I'm just kind of being rough with it because I don't care if I really do any more damage. It's not like it's going to hurt it anymore. Oh, it's really tight. They don't need these holes to be that tight. Every single one of these pads came off. No joke. Every single one. I kind of just want to take this amp and throw it in the garbage right now. I don't even want to work on it anymore. I don't have my good wood-handled screwdriver. Like this, it's stuck on the thing too. I can't get it out. It's loose. It's wiggling in there, but you can see them moving. But it don't want to come out. Let's pry it out. Let's have some fun with it. Get a little mean with it. Yeah, the second through hole's completely gone. Just ripped that one completely out. That's cool. Yeah, I don't know what version of board this is, but so okay, so this is a Rev 2. What Rev is this one? This is a Rev 0. So the older boards were definitely higher quality boards. They did work, or they were easier to work on. These newer or latest generation or whatever they are, they're really freaking hard to work on. And I mean, you do a ton of damage to the board. It's, I don't know, it's frustrating. So all the tops are still good, but none of the holes are good. I'm gonna replace the connector on here if I have a I have one with enough pins. I want virgin pins going through the new holes, so just one of those nights, I guess, days, whatever. I'm gonna check the gate drive resistors to make sure they're not shorted. These should be on 220 ohms. 222 and 220, 2.8. So those are still good. Pdc board. You can see where the glue has come in contact with the board. So all this glue needs to come off of here. We can try heat first. 110C. And I'm just going to heat it up. Heat it up with some hot air. Not hot air should soften this glue a little bit if it's still workable. If not, it'll just dry it out a little more, so it should flake off better. You got to be careful around these guys. You don't want to put too much heat by these Carly caps. They're really sensitive to heat. So we'll heat that up a little bit, and then we just take our dental tool, burn our fingers, and scrape all this crap off. This is what killed the amp right here. So we want to get all that, stuff out of there. Clean it as best you can, get most of the junk off, and then I'm going to take a wire brush, a brass wire brush and get the last little bits off. So I'm going to do that over the garbage can. And that's what we want to see. No more glue. I'm kind of surprised. I can't see that good. I don't have the schematic in front of me either, but I want to see if it actually shorted something out or if that was why can't I find my damn magnifying glass? There it is. So in between two of the pins there, and I'm trying to get it so you guys can see it. I know this light doesn't help, but right there where the tip of my probe is, let's just zoom in on the camera, see if that helps. That's a little bit better. So I'm just checking to see if there's a trace in between these two, and there is. So I don't really know what that glue was actually shorting out. It doesn't really look like it was touching nothing that it shouldn't have, so I don't know. Pdc board might still be good, but this board, you know, the glue was mainly right here, unless it was going from like here to here between these two diodes. I don't know. But the main blob of glue was like right in there, so it should have been alright. And we'll test the board out, make sure it's good. It's a self-oscillating circuit, so maybe I don't replace this. Since it is a full header, maybe I'll just clean it up. Clean it up and see if it'll fit in the tester. Usually they don't, but we can always try, right? Save a little bit of time. I'm going to take my X-Acto and I'm just scraping the pins. And the reason I'm doing that is to get any solder balls or blobs off of there. I'm not scraping them hard, I'm just going over them lightly to just clean them. I want them to be nice and straight, with no solder boogers or anything like that on there. So let's see, how many through holes do we have to replace? We have to replace 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 through holes on one tiny little part of the board. God, that it makes me mad. Makes me mad. For the glue by the Carleys, we're gonna try and just cut away as much as we can. This big guy, we're just gonna destroy him, pulling him out. This one's kind of a pain to get out too, because it's so heavily glued in there, but we'll try to be nice to him. I suspect we're gonna run into some other through-hole issues, so let's just see where we go and where we get. We do have to replace our IRF 730s. We're gonna replace both of those. You don't really need to replace both. You can just replace the bad one, but let's zoom back out here while I'm inspecting. So I think this was our bad one. No, this one. Come on, meter, be nice to me. Yeah, it was this guy. So this guy's bad. These ones look like they use mica insulators. I'm not sure, because they're smothered in 2 pounds of thermal paste. Alright, let me turn my solder sucker off and let that cool down. While that's happening, let's test the Pdc board and see if that's got any life in it. So we'll just take it out of that one and throw it in this one. And granted, even though this is for a sub 10 transformer, it'll still work on a sub 12, just not optimally. I just want to make sure that it still oscillates. That's all I care about. And if it oscillates, that means that we'll get voltage across our regulators. So if I get voltage across the regulators, we're good. If I don't, then I gotta repair the Pdc board, which is doable. Alright, we're going current limited. And we have voltage, so the Pdc board is good. I'm going to guess that this had a quick failure. Let's discharge our caps. Always discharge. Here's our big boy. Little spark there, probably a bigger one here. Yeah, not bad. Still. Discharge. Don't want to get zapped tonight. That would just really make my night not fun. Okay. Soldering tip is still too hot to remove. Now, if you really wanted to get these parts out without doing any damage, what you could do is could have just cut the pins out, but then you have to replace the header. But if you don't want to do through-hole repairs, sometimes that's the easier way to go. Just get down with a pair of nips and just cut all these pins right here at the top. Then pull them out one by one with a little bit of heat. It's probably the safer way to do it. Alright, heating back up, I'm going to remove this cap. And then I gotta get the through-hole kit out, start that fun process. I don't know, I'm still kind of thinking I should have just threw this thing in the trash the second those first two pads lifted. Might have made me feel better. I hope I have enough eyelets. If not, I'm going to be in a world of hurt. Hopefully these fit. Moment of truth. Does the pin go in? Yes, it does. Does it go into the old hole? That would be the ultimate. Because then all I have to do is just smush them. And no, they all are going to have to be drilled. Lucky me. Alright, we'll save that for a minute coming up here. No matter what you do, you almost always have to clear these twice. The lead-free solder is really a pain in the ass to get out of the larger through holes. So we clear it, resolder it with lead, then clear it again. I'm going to do that on both of them. I should be using my thicker solder, but it's all wrapped around something over there. Get some heat in there. That's nice and clear. Lead is so much better. You know, countries have stupid rules, like can't use this, can't use that, lead's bad, blah blah blah. Well, when they stopped using lead, that's when all these problems started happening with board failures and all that stuff, so kind of makes me think it was a bunch of bullshit and it was all planned just so people would have to buy more boards. I don't know where my big pliers are, so I'm just gonna find anything I can and break that bad boy out. Alright, so you can see the glue. The glue's not terrible. It should come out fairly easily. This one has the old style Q5 in there. I'm checking to see if it shows any signs of heat or failure. I'll probably do the transistor mod on here. I do it on all the other ones. I probably should just do it on here and not even think about it. For the glue on the Carlies, we're just going to scrape it off. It's okay if you get a little plastic too with the glue. That ain't going to hurt nothing, but just anywhere that this conductive crap is in there, we want to try and remove it off. Doesn't have to be spotless, just good enough. It's a shame too, because I mean these are pretty good amps, but this, whatever version this is, with the crappy boards, really is not fun to work on. And we're gonna get the glue, you know, heat the glue up a little bit. That softens it and it makes it a lot easier to come out. All they had to use was silicone and these would never have any problems. Aside from caps going bad. It's a shame. It really is a shame, but oh well. Gives me something to do on a Monday night when I'm not feeling good. Alright, that one came out nice and clean. That's what you want. All those chunks of glue out of there. Alright, what is this? 470 at 200. We have plenty of those. We got fat ones, we got skinny ones, we got tall ones. Got ones that have big long legs on them. I'm going to use a snap-in. Negative goes towards the transformer. Alright, replacement cap is in. It's a little skinnier than the old one, but a little taller. That's fine. Won't hurt nothing. Alright, let's do some through holes. Get this light out of the way. Well, maybe the light's kind of nice. Let's see if I can aim it without having it in view. Alright, nope. I'll just put it over on the side here. Have it blind me so you guys can get a better shot. Alright, we need this, I need this, I need this. The one thing I do need, I don't have down here, is my micrometer. Or my calipers. Because I need to know what size I have to drill these holes. I'm gonna guess it's this drill bit. Close enough. Let's try. We can always go one size up if we have to. Where is my... I've been looking for this drill bit, and there it is. Not put away. Alright. Let's find out which holes are bad. So, hole 1, 2, 4, 5, 6, 7. 1, 2, 4, 5, 6, 7. Here we go. There's 1. There's 2. 4, 5, 6, and 7. Granted, that might not be the right drill bit. Then we have 1, 2, and 1. 1, 2, and 1. So those are pretty good. Alright. This is one of the worst ones I've had in months and months and months and months. Kind of unbelievable, actually. And I lost an eyelet. Where did that eyelet go? There it is, I found it. Let's get rid of that garbage cap. And we're going to swage these from the bottom. So I am going to drop them in. Hopefully this goes in. I might have to go one size up on the drills. Come on, get in there. Nope, ain't gonna fly. Need one size up on the drills. It's not that one. I haven't done through holes in a while. I'm rusty. And I don't know where the drill bit is. Where's my drill bit? I used to keep them in the tubes, but let's see. Here's this one's gonna be too big, I think. No, maybe not. I think this is the one. Looks too big, but we'll find out when we try to drill the first hole. I think that's it. Let's try again. Yep, that's it. Wrong drill size. So what was that? That was 1, 2. Well, these are all going to have to be top soldered as well, so 1, 2, 4, 5, 6, 7. There's 4. 5. 6. 7. So, you know, what can you do? I was fairly careful with these things to start, and then I just didn't care, but there's no way that you should lose 7 pads just desoldering. I'm running the normal temperature that I normally use. I mean, there's no reason for it. It's just a lot of extra work for no other reason other than this board being so freaking cheap. But, you know, if you want to do a good repair, you gotta bite the bullet and do this crap sometimes. If you're working on your personal board and you have to pull the PDC and you don't have a solder sucker, cut it out. I'm telling you, save yourself the headache and just cut it out. You don't want to be replacing all these through holes. Luckily, none of them carry power. These two on the ends, they did loosen the pads a little bit, but they're still attached. So I'm going to leave those as is. And then what I'm going to do is just flare them all out. I'm just running an all in from the top just to make sure that they're sized right. And then I'm going to get the anvil and lock them all in their place. And every one of these is going to get top soldered too. There's no way around that. I'm just going to flare them on the bottom just because all I want is mechanical connection. I really don't care about connection on the bottom. So I'm not going to smush them flat. I'll show you a close-up of what this looks like when it's done. Such a freaking pain. But the nice thing is if this board's ever worked on again, well, there's only 2 more through holes I can fail. I know that's not the most reassuring thing, but... Alright, here we go. We'll zoom in. I wish the camera didn't drift when I zoomed. But there you can see it. Now they're all there. An extra, what, 20 minutes for no reason other than cheap Chinese freaking circuit boards. Now these ones I'm going to flare on the top because the connections are on the top and they have long leg devices going through them. So it doesn't really matter which way they go, but if you kind of pay attention to how the board's configured and what plugs into the through hole, it'll help you figure out which way you want your replacement vias to go if you have to actually replace any. Like I said, this is overkill. I mean, this is insane for this board. And honestly, I should have just threw this board in the garbage. I have, you know, other boards laying around. I could have just swapped one in and called it done, but we'll make a video out of it. And again, I'm not flattening these out perfectly flat. I'm leaving them coned. And the reason I leave them coned is because then they accept solder better. Alright, let's put the Pdc board back in. We don't have any more shorting glue back there. One of the things I am going to do is I am going to solder all these first, because there's a piece of plastic on the legs of those, and I want to make sure that that piece of plastic doesn't stop the solder from flowing around these. So what I'm doing is I'm just hitting the edge of each one of these vias with solder. And you might bridge one, it happens. If you bridge one, just suck it out. But I want to make sure all these have a really good electrical connection. I don't want them to arc. So, I mean, make sure you get a, you know what, here, I'll solder over the whole damn thing on all of them, and we'll just suck them all out. I want to make sure they got enough solder on them. Can't damage them any more than they have been. Now I know it'll get a nice good connection on there. I'm going to clean up this board a little bit more. Just by the base of the pins, you know, if there's any plastic that melted down, just kind of scrape it off of there. Sometimes when these things get some heat to them, the plastic does travel down the pins a little bit, especially when you're solder sucking. So just make sure they're good and clean. Now we'll solder that guy back in. I am going to use a little bit of flux on these. And I'm just using a liquid pen because I want to make sure that the solder does flow. Make sure our board is aligned. And then we'll solder that in. Alright, Pdc board is back in. It looks good. It's a little crooked, but I don't want it touching the capacitors, so that's okay. I'm going to allow that to be crooked just a little bit. Let's move on to this. We can put our through-hole stuff away for now. I have this feeling that we're going to need it again, though, so I'm not going to get too excited. These eyelets are not cheap, so try not to lose any of them. Alright, on to this beast. Now we have one bad one. This left guy here. I'm going to replace them both. They're IRF 730s, and I have a ton of them, so I will replace them both. You can see the thermal compound on these is long gone. There's our new parts. I'm gonna What's the purpose of thermal paste if it's not even good anymore? So I'm just going to try and get as much of this old junk off of here as I can. Even those insulators are in horrible shape. Again, this is what happens when you leave your amp plugged in and turned on for extended periods of time. Everything gets dried out, everything gets destroyed. I'm just cleaning up these mica insulators a little bit, just taking all the nasty dead thermal compound off. We'll reuse them. I could just replace them, but well, these aren't too bad, so I'll just reuse them. I'm just glad to see that Klipsch got away from using those ceramic like blocks they used to put under these things. Ceramic is not an heat transfer material. It's an insulator. That's why they put ceramic tiles on the front of the spaceship. It does not pass heat. At least not very well. Alright. I want to try and get all this crap off my bench. If I just get this white shit everywhere, I'm not going to be happy. Alright. Let me show you how to put thermal paste on a transistor. It goes in these first two spots. Ready? Oh, hold on, that was silicone. We want this one. That's it. Can you see that? See that little spot right there? That's it. Now watch this. When you put that little spot on something flat, and then you put it under pressure, that little spot becomes a big spot. And when you tighten the screw down, it becomes a really big spot. And this is Dow Corning 640 that I'm using, so it's not garbage, it's actually good stuff. I just don't like using a lot of it. You should never, ever, ever have thermal paste leaking out so bad that it gets all over your fingers. Same thing on the device, is one tiny little blob. That is all you need. One little tiny spot. It transfers heat better. All you want to do is just be able to, hold the parts in place kind of until you can get everything screwed back in. We want to make sure they're nice and straight. As good as we can get them. I still got that crap all over me. It's like unavoidable. I waste more darn paper towels cleaning off thermal paste than I do using them for what I should be using them for. That's why I like using silicone mats though, because the stuff does clean off pretty good from those. Alright. You want to make sure your little insulators are going through the hole in the insulator and into the heatsink. Make these fairly tight. You don't want them to be loose. Make sure they're straight. If they're not straight, loosen up the screw, adjust it, and tighten it back down. There we go. Alright. Now we're going to put this back in, but we are going to... Look at that. I got more of it on me. It's like I'm being attacked by this shit. I can't win. I can't. The battle is lost. Just thermal paste everywhere. I should have went with my gut and not did a repair video tonight. Alright. Let's get this darn thing screwed back together. So I do need to find a missing nut that went rogue on me. I'm sure I have some in my little hardware box. But you want to always screw in the heatsink before you solder. Because the legs sometimes need a little wiggle room to move around. Not stupid tight, just medium tight. Let's see if I can find that nut. I don't think I'm going to, but we can try, right? Take a look around. I'm always worried it's in the bottom of my coffee cup. Did it fly under my mouse pad? No. Is it in my tools? No. It's not in my drawer. I don't know where that darn thing went. It's probably somewhere really bad where we don't want it to be, though. Either that or it fell on the floor or on my lap or something. Hopefully not. Oh well. We will find it another day. Right now we're going to steal one from something else. I have a hardware box. Oops, almost lost my headset there. Bear with me. Klipsch hardware box full of screws you might need, and I'm looks like I don't have one, of course. I have some. Well, that one's gone. Let's see, maybe this is the right size. Oh, I do. I have one. Potentially had two, but one of them hit the floor and bounced somewhere, so that's... Oh, actually, no, that's a totally different nut. Not even the... I'll find that one next year. Alright, for now we do have a replacement. I am just looking over the transformer to make sure it didn't get like stuck underneath the pins on that. That would be about the only thing that would be really bad. It's if it got jammed under there and you went to go power on. Luckily these are fairly universal. It is a tight area though, so you almost need 3 hands. Alright, heatsink is on. Good and tight. Now we gotta solder in the transistors. Again, I'll hit them from the bottom. I'm hitting the sides of the replacement through holes because I want them to wick into the original through hole as well as down the center. So I want to make sure that you're connected on both sides of the board, and I want to make sure that it's connected anywhere else that it potentially would have been. Then I'm going to check the top and make sure it flowed over the top on all those as well. So I'm going to actually go back and top solder all these too. And I know you guys can't see this very well, but that's just for me, just to make sure that everything is soldered super good. And everything does. That first one needs another little hit. Everything looks good. Alright, at this point, the amp should work. Put the main cap back in. I'm going to use the big boy to use the right size solder this time too. Solder the big boy back in. I mean, it's actually a pretty small cap for most standards, but get them in there, get a good joint, heat it up, let the solder wick down in there. Okay, phase 1 is done. Let's see if we have power, or if it blows up. I'm pretty sure it won't blow up, but let's see what happens. We're going to go current limited. Doesn't really matter if you have line or neutral cross, but I like to hook it up properly anyways. Let's get our meter. Let everybody share in the fun here. And I know that's hard to see. Yeah, that's better. Let's stick something under there. Put some desoldering braid under there so y'all can read it. Good enough. Alright. Here we go. Current limited power on. And it's alive. 27 volts. I never remember the polarity on these, but positive is on this side. This is the 30 volt supply that comes off of these two diodes, and that's for all the low voltage electronics. Let's check the bash board now. Here, let's power back on, and I'm carefully just going to go to these two front legs of this resistor, 5.1 volts. Turn the power off. So I checked between these two legs here and here, and if you have 5 volts on the front side of these two resistors, that means that the bash board is working. So we're going in the right direction. Now we have to get this guy out and finish the recap. And I think I'm going to cut these out. I don't want to go through and replace a ton of through holes, so I'm just going to snip them all out one at a time. I'm going to lose my mind if I have to do, 20 more through holes on there. And these are all bent leads too, so that's all the more reason I want to be a little bit nice to them. Discharge. 2 main discharge points. Big cap, little cap. This cap here holds close to 100 volts. And it's only a 100 volt rated cap, which is kind of weird, but it should really, and some of them actually use a 160 volt rated cap, but this one is 470 at 100, so that's what it's going to get. If I have them, I'm pretty sure I do though. 470, 160. Yeah, I got them. I got good ones. Nichicons. These are incredibly difficult to get out. Especially when they're glued in as well as that one. So I am going to add solder first. So now what I'm going to try and do is break the seal between this and the board. Nope, we got lucky. It just popped right out. Normally you don't get that lucky. And we didn't do any damage to the board. That's double lucky. Alright, I gotta get this glue out of here, so we gotta go to the heat again. The glue really isn't in bad shape, but it will become bad, so it has to be removed. So I'm going to just heat it. This is 100°C. And I'm just heating it up till it gets kind of soft. And I'll probably have to do it a couple times, but once it softens up, I'm going to get in there with my dental pick, if I can. It's going to fight me. It is going to fight me. And there's really no easy way to get in there. More heat. Since this glue is kind of fresh, it sometimes is more difficult to get out when it is this fresh. And the only way to do it is just to heat it up more. Use your dental tools to work it out. It comes, you just have to be a little patient, and I'm not being patient tonight. There we go. And this is a rounded dental pick, so I'm, you know, not really risking any damage to the board. I'm just popping all this glue out. There's a nice chunk. Anywhere where it really touches the board, you gotta get it out. Under the legs of this little capacitor in here, it's gotta come out. Just gotta work at it. You know, be careful, you don't want to damage the board, but if you get 90% of that out, you'll be doing yourself a huge favor. Underneath the dashboard, it's critical, it has to come out. That chunk. There's still some more on the board. Gotta get it out from under the dashboard. If you did nothing else, get it out from under there. You don't want to damage this board. Damaging this board is a pain to fix. Especially then you gotta take the heatsink off. You gotta worry about damaging the through holes. You gotta get this epoxy off of that chip that's under there. I mean, don't do it. Clean the board up now. It's working. And you'll be much happier. Alright, so now I'm going to snip the caps out. And then I have this little tray here. I know what order they go in, just because I've done it, but I'm going to line them up here just so they don't get put into the wrong spot. I'm top cutting them. These are cheap caps. Who makes these Junzels? What the hell is a Junzel? But as close as you can to the board, snip them off. And we're doing this to try and avoid tearing off through holes. That doesn't mean we'll be successful. Just means we're trying. You need a good pair of nippers. If you're working on this stuff and you don't have a good pair of nippers, just stop and order a set. They're $10 on Amazon. These are Heiko CHP 170s. You use them for everything. Very, very, very good set of nippers. These last two are bipolar. You know, you might have to dance them around the leads a little bit. It ain't too bad. Alright. Let's see, there's a little bit of glue left under the cap. Can kind of scrape him off before we desolder. I need to mute you for a second. Hold on, please. Alright, coffee break. Alright. And headset adjustment. Now we want to pull the cap leads out. So we have a hot iron and a pair of tweezers that are mildly magnetic, even though they say stainless on them. So we're just going to heat up the pad a little bit and pull out a leg. Heat up a pad, pull out a leg. And we'll do this for all the cap legs. And this still doesn't mean we're home free yet, but it's helping. You can see they do come out easier. I think this is one. No, that's not one. This is one. This is really not the right tip for this, but you should be using it is one of the legs. Sometimes they will fight you. Get a little more heat in there, not too much. Depends on if it's hooked into a ground plane or not. Yeah, it's one of them also. The goal is to take your time and not damage the board. Because we'll come through and clear them after the legs are all out. This is lead-free solder too, so keep that in mind. You're dealing with the worst type of solder imaginable. Takes a tiny little bit more time this way, but you know what? If it saves me having to do one through hole, it's totally worth it. Then I could take the solder sucker and just real quickly might have to add a little more solder to some of them. Some of them don't behave. Depends on what side of the board they're grounded on. Alright. Oh, we got one more to clear. This guy right here. Forgot about him. Alright. So that's another way to do it without doing damage to the board. You could still lift a pad doing it, it's just a lot less likely to happen. And since the board is marked, we're just going to work our way backwards. The first one should be 47 at 50 volts, which it is. Then the next one is, I think, 100 at 25 volts. Then 47 at 50, then 100 at 25, then 47 at 50. And another 100 at 25. So 47 microfarad, 50 volts. Need 3 of those. And then 100 at 25 volts, we need 3 of those. Your caps might be different on your board depending on when and how it was made. I'm just replacing these with what was in it. So we'll start at the top and work our way down. Home stretch. I'm going to change tips just because I want more heat. Go back to my hoof style tip. And back to the fine solder. There we go. I'm tacking a lead, and then I'm going to solder the body. then go back and solder the lead, and then bend them out of the way a little bit when they're dry. We can put the big boy in too. Minus goes towards the dashboard. I'm bending the lead not to hold it into place, just to keep it from falling through the board while I get some solder on the first leg. So, since this is a large plane area on the board, what I'm going to do is hit them with the higher powered iron. Leave a little bit of a lead length for fillet, but get in some heat in there, and work that heat around to make sure that you got a really good bond to this cap. And I'm going to do that with all these too. I'm just going to go around and make sure, because a lot of these go into ground planes. Alright, so first one was, next one's 100. I think they just alternate all the way through. I always forget that. It goes 4700, 47 100, 47 100. I'm pretty sure, yeah, that's how it goes. Here, we can put a few of them in there and try and get them all tacked in at one time. Just make sure you get your polarities right. The board is marked, but just double check. The square hole is usually positive, but not always. I forgot to clear the holes on that one. Made a mistake. 47 100. This should be... Where's my other 47? There it is. 47. It should be 100. So yeah, don't make mistakes like I'm doing. Make sure you put the caps in the right spot. So it's 47 100, 47 100. 47, and the last one's 100. I'm not mushing these down. I have to clear the holes on that one. I forgot to clear them, so make sure they're staying in there nice, kind of nice. And we'll go ahead and tack one of the legs. And I'm just blobbing a solder blob just on one of the leads. We'll position them after we get it tacked in. So you make sure they look, kind of good. Check your polarity again. Round hole is negative. Those all look pretty good. So now we can go ahead and solder them. Solder the leg that we did not tack, then go back and resolder the one we did. And we're going to go over these all one more time too, so just because there's a big ground plane on the bottom here and I want to make sure they're in. One more, and I did not pull the leads out of this one, so that is this guy here. You can see how hard it is to melt that solder. That's lead free. This is our last 100 microfarad cap. Alright. last guy in there. Again, make sure our polarity is correct. Negative goes to the round hole. Tack it in place and solder them in. Good enough. Now we're going to clip all the leads. Leave a, you don't want to cut them flush. Leave a little bit of lead sticking out. It ain't going to hurt nothing. You want to leave a spot for a nice solder fillet. And then we're just going to take the solder sucker, just because it's much higher powered, and we're just going to dance it around each one of the joints that we just did. And what that's doing is it's just allowing the solder to flow through the via where there's a ground plane. So it just when you have these large copper areas on here, they suck the heat right out of the smaller iron. This bad boy can easily overcome that. So there we go. There's recap. We got the two non-polars in the front. These are forever caps. They're actually pretty good non-polar caps. So I am going to leave those in. If you want to replace them, you can, but generally the forever ones usually do seem to be pretty good in the audio path. And this amp, I mean, it's in pretty good shape. It does seem to have, low hour on it. The Junzels, like these gotta go. These cheap electrolytics gotta go. But the forever caps are decent quality caps. And they're in the audio path. So these ones can stay. Everything else has to go. And I don't generally recap the preamplifier boards because they use the forever caps in them too. And out of most of the, of course I say that. Now this one has two Junzels on it. But out of all the amps I've worked on, I think I've seen one failure in the preamp. It's very uncommon. They're very lightly loaded. They don't get hot. Whereas these caps get cooked by these voltage regulators here. And this cap really is a little bit underrated. And this one, I don't really see the main ones going too much, but this one's usually smothered in glue. So that's generally the problems you see with these. But now it is redone. And since Q5 looks good on this one, I'm going to leave Q5 alone. There's not even a faint burn on it. I know you guys can't see it. I can see it through here, but usually you can see if there's an issue with Q5, there's usually some discoloration on the board. And I mean, this one just looks good, so I'm gonna leave it alone. Some amps Q5 has a lot of issues. Some they don't. Like I've replaced Q5 on this one. I used to use a surface mount part, but you can clearly see the board is discolored because it got way too hot. We'll test fate and see what happens with this one, but it should be fine. Can always check it after I run some testing on this. I'm not just gonna kick this out the door and call it good. I'm gonna actually test it a little bit, let it get heated up, make sure it is happy running, 75% load. We got to do a test, so let's get this thing back together and test it out. Figuring out which screw goes in which spot is half the battle. I don't know why they mix plastic and brass screws. Like, how many pennies could you save by using one less standoff? Like, come on. I know Klipsch isn't that cheap. Alright, get all the brass ones in. Snug them. Not tight, just snug. If you put them in there too tight, you're going to snap a screw off. Then you're really going to be mad. Finding those screws is not too bad. Finding the standoffs, that might suck. Because I doubt you'll be able to buy just one. You'll probably have to buy 20 of them. You'll notice I didn't put any thermal compound on the bottom of this heatsink. That's because there's still plenty left on the plate. And if I'm going to be honest, this really isn't a great thermal interface anyways. It's kind of a terrible design for heat transfer, but what the heck do I know? I'm just a mechanical engineer. Oh wait, that's right, I studied heat transfer. Anyways, yeah, it's not a very good good way to dissipate the heat. Better way would have been to put the transistors right on the plate. That's how I would have did it, but I don't get to make those decisions. But the little bit of thermal paste that's on there will surely conduct the heat out of this thing, no problem at all. Alright, 2 more screws and we can test this bad boy. Make sure it's got a nice clean audio wave. Okay. Only a couple of marks on there from that crap glue or thermal compound. Let's hook up our line. We gotta put a new fuse in it. I gotta grab a new fuse. This should be a T2L. I always check the fuse because usually people 2 amp. Usually people put like a 5 amp fuse in here and they really get these things good and fried because they use the wrong fuse. Okay, let's get a fuse. Make sure it's a 2 and not a 3.15. I use slow blows, T2L. T2L. Slow blow. So, this is 2 amps at 120 volts, so ideally this would be 240 watts peak. We're going to turn the gain all the way down. We're going to turn the hertz all the way up. Stay at 0, and I guess we'll leave it on auto. I hate the auto feature, but we will leave it there because the next person that owns this is going to put it there anyways. Alright, speaker hooked up. Everything is plugged back in. Let's give it a go. Oops, hold on. Time out. We need an audio signal. There we go. Power switch on. There we go. We have green lightage. Let's see if we have 36 hertz. Oh yeah. I hear 36 hertz. Let's show you 36 hertz. Bear with me for a second while I scour my disgusting bench top here. My project over holiday break was supposed to be cleaning up my bench and getting it like usable and organized, but yeah, that just didn't happen, unfortunately. Not because I didn't want it to, but I just wasn't feeling good, so you know, everything that I needed to get done got shelved. It's unfortunate because I had a lot of projects I wanted to get caught up on. But that's the way it goes. What can you do? Can only cry about this pandemic and all this crap so much, and then it just gets boring and nobody wants to hear about it anymore. And I know I'm not the only person going through it, so it is what it is. You know, a lot of my friends and family, you know, told me that most of the people in their families, you know, were either sick or they had to cancel the holidays or you know, something, so at least I made it through Christmas. I'll give myself a kudo for that. I do not know where my good test clip is. I do know that I have a bad ground on my audio connector. I'll use my little alligator clip one. I haven't used this one in a while. It works okay. Alright, hopefully the batteries are good in this thing. They appear to be. Speaker plus is... You gotta be a little careful putting alligator clips on these things. You don't want to short the outputs out, and these are the cheapest alligator clips imaginable. These are probably the ones that came with this cheap meter. But we'll carefully get them on there. And we can see audio. Let's go 36.6 hertz, and I got 36.0 going in, so I love this little meter. I know it's a piece of junk, but for doing you know, little demonstrations and testing like this, it works great. You can, I mean, it's a beautiful sine wave. I don't want to go up too loud, but it's a beautiful sine wave. Here, let's zoom in on the sine wave. And all the crud that came out of this amp. There we go. I don't know if I've ever zoomed in on the cheap meter before. But I mean, you can see there's no distortion on the waveform. Even if I crank it up, and I'm still running current limited. You can see the, you know, it's showing 39 hertz just because it's not getting enough samples to actually measure the waveform. So as you bring it down, it'll actually be able to calculate a little better. So now you see we're reading 36.1, but the waveform is like so compressed you can't really see what's going on, so you lose a little bit of accuracy, but it's still showing the correct waveform. So not bad for, you know, a $10 little meter or little scope that's been modified to run off batteries. Man, I love this thing. So, alright, there we have it. Klipsch RPW-10 restored. It was a pain in the butt. You know, we broke a lot of through holes trying to take the Pdc board out and the transistors, but we got it out. Everything has been repaired. I'm going to do some testing on this, and then I will, you know, get it back in somebody's living room and get another one in here to work on. So, thanks for tuning in. Please remember to like and subscribe. And if you have any video requests or any questions, please, you know, comment, and I will try to get back to you as soon as possible. So thanks for tuning in. I might do another one tonight. I don't know. This one was what, about an hour and 3/4 long. I'll see what I have. If I have something that I think might be quicker, I'll do another video. If not, then maybe we'll see you tomorrow. Thanks for